Hello everyone, this is Steve. Thanks for joining me. We're going to graph this polynomial, and it's completely factored, and some people might be a little bit intimidated by this polynomial because it has the fraction in front of the whole thing, but for the purposes of sketching a graph, it's really not going to matter that that's a fraction. What does matter is that we do have that fraction as our leading coefficient. But I don't really care that it's a 1/2. All I really care about is that it's a positive number for our leading coefficient. And we're also going to need the degree of this sucker, so let's see what we got here. 2, 3, 3, 1. So it looks like our degree is going to be 9. The 1/2 does not contribute at all to the degree. We would need to have an x or an x to a power in front to contribute to the degree, but the 1/2 is just the leading coefficient out there. So our degree is 9, which is odd, and that means our end behavior is going to fall left and rise right. Okay, let's look at our zeros. So I like to write them from smallest to largest, so we're going to have a -4, and we're going to have a -2, and we're going to have a 2, and a 4. Those are all real numbers, so we're going to convert them into x-intercepts. So -4, 0, -2, 0, 2, 0, 4, 0. Multiplicities. Just look at the power on the factor associated with the 0 or x-intercept. So the one for -4, that was right here, so it's going to be 3. The one for -2, that was right here, so it's going to be 1. The one for 2 is going to be right here, so that's 2. And the one for 4 was right here, so that's going to be 3. 3 plus 1 plus 2 plus 3 is 9, so our degree does match up with the sum of our multiplicities. And now we'll write down our behavior based on the multiplicities. So let's see here. Cross for just a multiplicity of 1. A bounce, which is sometimes called touch and turn around, but I like to call it a bounce. And then if we have an odd multiplicity bigger than 1, like 3, 5, 7, 9, so on, then we're going to do a cross and flatten, or you might call it a wiggle. All right, do we have everything we need? We have our zeros, their multiplicities and behavior. We have our end behavior of the graph. Let's go ahead and sketch a graph. All right, to make my graph satisfactory and easy to draw, I'll go ahead and put these little arrows in here to indicate my end behavior. And then I'll go ahead and put in my x-intercepts. So -4, -2, 2, and 4. Okay, now I'll have to do the behavior for each one. So at -4, we're going to do a cross and flatten. At -2, we're just going to do a cross. At 2, we're going to do a bounce. And at 4, we're going to do a cross and flatten. So because of this arrow down here, I'm going to start my graph down here below the x-axis and do the appropriate behavior at each x-intercept before exiting up here. All right, so let's do this. Cross and flatten. Come up early like you're going to do a bounce, but then you end up crossing. You got to flatten on both sides of the x-intercept. Don't go too far that it's too late to get down here with a nice smooth curve. That doesn't look good at all. So make sure you keep it nice and smooth. Come down and do your cross. Nice and smooth. Coming up to do a bounce. Come up early enough to do a nice smooth bounce. And then come up early enough to do a nice cross and flatten. That's a little bit boxy. I don't care for the way that came out. Let's try that again. Well, some people might not see the difference, but I like it better that way. Okay, that's our graph. Sometimes you do make a mistake, doesn't look quite right, you need to erase and try again. All right, I hope that helped. Thanks for watching.